Hello, good day everyone. My name is Irfan Haq. Welcome to Hi-Fi Tech Group. We will be discussing overlay tunnel today. And this is one of the most important topic in CCNP 350-401. Overlay tunnel are part of the CCIE course as well. So the candidates who are preparing CCNP and preparing overlay tunnel, they should prepare it well to just prepare themselves for their upcoming CCIE exam as well. So in this course, we will be discussing uh, following four topics. So the first two topics, they are related to tunnels. So the first one is GRE tunnel, and there is no security in this one. And to overcome the security issues, they introduced IPsec tunnel. IPsec tunnel, it is like a GRE tunnel, but it is with security. And then the third topic is LISP. So this is to reduce the internet routing table size. Routing table size. So it is a very good technique at the moment. Our public internet, it have over, it have around 1 million BGP routes. And if we use LISP, so we can control our public internet routing table size. If we don't use Lisp, then the public internet table size could grow to 5 or 10 million or so on. And then the fourth topic is VXLAN. VXLAN, it is like VLAN. It is the next form of VLAN. It have some advancement. So normal VLAN have 4094 IDs, but VXLAN, it can go up to 16 million tags. So these are the four topics that we will cover. So in my first lecture, I will be starting with the GRE tunnel. Then there would be a lab for this as well. That would be a separate video. Then in lecture 2, IPsec tunnel, I'll compare it with the GRE tunnel. Then lecture 3 would be Lisp and lecture 4 would be the VXLAN. So without wasting time, let's start with GRE tunnel. So GRE tunnel, it is basically a way in which we encapsulate packet within a tunnel and send it across. So this is the header of the GRE packet. If we see, this is the data and the original IP header. So we add GRE flags on top of that and GRE IP header. So this is how the GRE tunnel look after adding additional header on top of the existing original IP header. Please note that these GRE IP headers, they are GRE source IP and GRE destination IP of the tunnel. So GRE source IP of tunnel and the destination IP. So when the packet go through the MPLS backbone or through the internet consider it as a normal IP packet. They don't know what is underneath. Underneath, it can be multicast traffic, it can be IPv6, whatever, it is transparent. So for the public internet, it's like a normal IP packet. there are many advantages of using tunnel setup. In this diagram, if you see, we have IPv6 LAN on one side, and the other side is IPv6 LAN as well. So let's say our infrastructure, it does not support IPv6. IPv6, it's not supported. So then how are we gonna do? We want communication between this PC and this PC for IPv6 traffic. So what we gonna do? The solution is basically we can pump in the traffic into the tunnel, IPv6 traffic from that PC when it go through the MPLS backbone or through this IPv4 network. IPv4 network, it will just see the top header, which is the IP packet. So, but inside whatever the traffic, a backbone network, it does not care. So basically, IPv6 traffic, it's coming into the GRE tunnel inside, encapsulated, and then it reach to the other end. So that's how we can pump in IPv6 traffic inside the tunnel, which go on top of IPv4 network, and then the packet reach at the destination. So basically IPv6 is going over IPv4. So IPv6 traffic, it is going over IPv4 network through GRE tunnel. So that's what we're doing. Let's look at now the header of the packet from PC1 to, for example, this is PC2. So from 10.1.1.1, from this IP 10.1.1.1, we want to send a packet to 10.3.3.3. So source is this 10.1.1.1, and the destination is this IP. And the payload, for example, we want to ping. When it reach to the tunnel, so this is GRE tunnel, and this is the source IP of the GRE tunnel 50.111. This is the source IP, and this is the destination IP of the GRE tunnel 100.1.1.1. So if we look at the payload now for the GRE header, now this is the same as it was there on the original IP header. This portion is same as it is. On top of that, we added a GRE packet, and then GRE tunnel source IP. Source IP is this one, and the destination IP 100.1.1.1. So basically, um, we just added the additional header on top of the incoming traffic from this PC. So when this packet will go through this IPv4 network, when this packet, it will go through IPv4 network. So this, it will go in the form of GRE tunnel, and the top in the top of the header, these are IPv4 IP addresses, so 50.1.1. So this IP, when it will go from router 1 to router 2, then router 2 to from R1 to ISP1, ISP1 to ISP2, and then ISP2 to R2. So this packet, it will reach to R2, and then R2, this is the destination router, basically where the GRE tunnel, it is terminating. So at R2, what gonna happen? This top header, it would be removed, and then this router, it will send the packet to the destination IP, which is 10.3.3.1. So once this packet received there, then this header, the second header from bottom, it would be removed, and the payload, it would be delivered here. So this is how a packet, and IPv4, IPv6, doesn't matter, it can go through the IPv4 network inside the GRE tunnel. So Let's say we want to pumping some RIP traffic, and this network, it does not support RIP. RIP is an old protocol and it does not supported by modern network routers. So what we're gonna do, that is the problem. RIP is running in this LAN, RIP is running, and we want to make a RIP neighborship between these routers. So what we gonna do? So here in the IPv4 network, let's say BGP is running. Now BGP, it will not, these routers, they don't support RIP, and RIP cannot run over on top of BGP. So what we gonna do? Again, the tunnel is there. We encapsulate the RIP packet inside this tunnel, and then within the tunnel, the packet, they will go from router 1 to ISP1 to ISP2 to R2. Then the packet will be decapsulated, and then they will reach to the far end. So RIP traffic, it can go from one router to other router, from one lane to other lane over public internet using GRE tunnel. Although underlay network, they don't support RIP. So we are creating an overlay tunnel, a GRE tunnel, and we encapsulate our RIP packet inside the tunnel, and there you go, it go to the destination. Another a very important advantage of GRE tunnel is to make communication between private IP addresses over the public internet. So this LAN, it have it is using private IP address range 10. 10.1 is private IP address range. Same is at the far end. This is the private IP range. But now router 1, ISP, router 2, they are using this public internet. 50, 100, this is public internet range. Public internet does not allow private IP addresses to be routed over. So private IP addresses cannot be routed over public IP addresses. They are blocked by the router. There is no way, but still we want to make a communication. Let's say this is a branch office and this is head office. We want to make a communication. Let's say we want a OSPF session in between these two locations. So what we gonna do now, these private IP addresses, but we can still make a communication between back office and head office if we use the GRE tunnel. So private IP addresses, they will be encapsulated within the GRE tunnel, and then they go to the far end and reach to the other PC. So private IP addresses, we make a communication in between the PCs over the public internet without any problem. Further, if we want to establish an OSPF neighborship between them, between this device and this device, let's say if we want to set up an OSPF neighborship between them. For example, it is a router. Let's assume it's a router. We want to bring up OSPF neighborship in between these two devices. OSPF come up if it's a basically directly connected. So if the two devices, they are directly connected, only then OSPF will come up, otherwise not. So here there are so many hops between this device 1 and this is device 2. So how many hops? 1, 2, 3, 4, and 5. OSPF can never come up because these two devices, they are not directly connected. But if we use the tunnel basically it consider it as the two devices, the source and destination, they are directly connected. So if the traffic go inside the tunnel, GRE tunnel, it will consider it as single hop. So mean the router 1 and router 2, they assume that they are directly connected. They basically the intermediate hops, they are transparent. So these two devices, then if we use the tunnel to route the traffic, so this device 1, it will then assume that it is directly connected to device 2, and that's how OSPF will come up. So that is another big advantage of using the tunnel to bring up OSPF session for two routers which are not directly connected. And lastly, let's say if we are using RIP over here and RIP over here, RIP have a limitation of 16 hops. And let's say between this device and this device, there are, for example, 100 hops. So RIP can never come up. But if we create the GRE tunnel, then instead of 100, it will consider at one hop. So then the GRE session, it will come up. So these are all of the advantages for GRE tunnel and also for the IPsec tunnel. Overall, the tunnel concept, it is very useful and helpful because GRE or IPsec tunnel, both of them, they encapsulate the packet, and then the device, then the source the router and the destination router, they consider that they are directly connected to each other. So I have taken you guys through these advantages. So GRE tunnel, please note that very important, it support multicast traffic and routed traffic as well, whereas IPsec, it does not. IPsec, it does not support multicast traffic. So GRE tunnel support IPv6 traffic as well. Private IP addressing, we can carry the traffic from the devices on the private IP address range. RIP can be, RIP traffic can go over BGP or whatever the infrastructure, and OSPF will come up because GRE tunnel, it considered that two devices, the source and destination, they are directly connected. So this is the lab. In our next video, we will discuss the lab for the GRE tunnel. We will implement a GRE tunnel between branch and head office, and then we will bring up OSPF's neighborship in between them. So please join the Hi-Fi Tech YouTube channel and click on the bell icon button, and please follow our YouTube channel and follow my next video, which is about the GRE lab. Thank you very much. Okay, bye.